So let's get started. So yesterday I left you with the graphical of a literate cow able to cite Mark Twain and other novelists. So let's start from there. Some key take-home messages about building container images are here in the slide. So we need some form of recipe that describes what commands to execute to build a container. So this is how you get some software installed inside the container for future usage. After that, there is a step, the actual step of building the containers, and this is done by using Singularity with sudo privileges. And once the image is built, you can then use it with the typical execution commands. And eventually you can share it either on public registries using Singularity push, or as Singularity images are simple files, just big ones, you might use typical file transfer utilities to share the image with your peers or across different machines you're using. So this is kind of the broad process. Now we're going to dive a bit more in detail into the definition file for a Singularity image. So let's go back to my terminal window, which is still open on a cloud virtual machine on the Pawsey cloud, the Nimbus cloud. And this is where we were yesterday. So we built the lolcow.cif container by using the lolcow.def definition file. So let's have a look at the contents of this file and try and comment on what are the main sections and the key syntax that you need to know if you want to write one from scratch. So you might see here and there are some typical Linux commands. Not many in this definition file because it was kind of a simple one. So you can see here a couple of Ubuntu Debian commands just to install software, and that's how we got basically the cow working by means of these three packages. But this is the typical Linux syntax, right? And then we have another Linux syntax, which is setting an environment variable for the installed packages to work as they should. What we want to focus now is on the additional syntax we need on the side of Singularity for our definition file to be formatted properly. So the first and key piece of information is the starting image we want to use to build our container image. And we need to specify two informations here. So one is the web registry where we're picking the image from. So we do that using bootstrap, followed by the type of web registry. In this case, it's Docker. So we're picking the image from Docker Hub. And then which base image we're actually using from the web registry. And in this case, it was Ubuntu tag 1804. So that's a starting point for any build. You need to start from some pre-existing image. And I'm going to show you later a slide where I'm just giving some suggestions. So based on the type of application you want to containerize, you might want to start from different images just to make your life easier. Then you see here is where we have the Linux commands that we're actually executing to install applications in the image. And in the Singularity definition file, you put these commands in a section that needs to be started with the label %post. So this is where you put all of the Linux commands in this recipe. Then we have the part where we are defining environment variables, and those need to go under the %environment section in a definition file. And I would say these three bits, so the starting image, the Linux commands, and the environment definitions, these are the three key components that you need in an image. If you know how to basically write these three bits, you're halfway into building a container image, provided that you already know the list of Linux commands that you need to install your software. And then we can have, so in this specific file, we have additional sections in the definition file. So we have a labels section, which is basically a place where you can add information, metadata to your image, and that can be useful for, not for you, but for other people using the image, in knowing, for instance, who is the author of the image, and eventually a version. You could put anything here in the form of a key and the value. So it's kind of free text format under this labels section. Interestingly, you can get this information from the final image by means of the command Singularity inspect. So if you do Singularity inspect and then the image file name, you get a number of strings, including the two that were defined in the definition file under the labels section. Let us just go back in here. So then there is a help section which where you can provide a quick help text that will be displayed when you run Singularity run help and the image name. This is possibly not always useful. Maybe if you have a more complex container with where the application needs some documentation of the usage, that might be a good place where you want to put that information. And then there is another section called run script, and I'm gonna comment on this soon. Let me just add a couple of comments from the slides. So on the key parts of the definition file, I mentioned 3 already. So the base image with bootstrap and from, the Linux commands with post, and the shell variables with environment. There is a 4th one you might want to know as in terms of key components, which was not used in this example, but you might often need. It's the file section, and here you would put a list of files that you might need to copy from the host machine into the container image that is being built. And examples of these might be, say, configuration files that you need to customize prior to building the container. So it might be just easier to have a copy ready in the host and just copy it in. Or there might be other cases of this type where you really want to just copy files in rather than building or downloading files from the internet in the post section with Linux commands. I've already touched on this. Let me just add a couple of comments. So one handy feature of Singularity is that with Singularity inspect, you not only you get the labels that you documented in the definition files, you can also get the output of the full definition files itself. And you can achieve that with Singularity inspect -d for definition file, and then the name of the container. And this is quite handy as well. And then back to the last section of the definition file is run script. So honestly, I don't recommend the usage of this one that much. And that's because what you get here, you get a default command. You get to choose one default command that Singularity can execute in your container with a simplified syntax. And you can actually get this just by running the image file as an executable. If you do that, you get the result of that command. And so it's here because it's nice to have just a very simple command to make the cow speaking. But other than that, I wouldn't recommend that for scientific applications, just because very often you have multiple commands to be executed from the same package, same blast. You might have blast m, blast p, and so on. And here you need to pick one for this special syntax. The other commands will still need to be run in the canonical way, Singularity exec, and so on. And actually, also similar way, you might even have a few packages that only have one single command, so you might use them this way. But then I can tell you that in all user cases I know, people always have in the software stack at least 1 or 2 packages which have multiple commands. And then this means that in the way they get used to using containers, they will need to keep in mind both ways of running, the simplified one and the full one. And so my take is, okay, guys, just keep on using the canonical way, Singularity exec, and that's it. Just forget about the run script, apart from this tutorial for the colorful cow. One last little comment on useful definition file sections. There is a start script section, and this can be used when you need to define commands for spawning long-running services from with Singularity. So say you need to run a long-standing RStudio or Jupyter session from a container, then the syntax is a bit different from what we've seen so far, and you will need to populate a start script section in the definition file. In the interest of time, we're not going through this specific example in detail, but this example is covered in the tutorial materials that are available online, and for which I will put the link back on screen at the end of this presentation for those of you that are interested. Just one last word. We mentioned the usage of base images, which is the starting point for building any container. You might just want to take note or think about these specific user cases. So we use Ubuntu there for base image, but there are other nice ones. So for Python, you have Python images that could be useful. If you are a Conda fan and user, Continuum.io, which is the company behind Anaconda, provides interesting containers that ship with Conda. If you use Jupyter notebooks a lot, there are Jupyter images that might be a good starting point. If you are a R user, there is the Rocker project, which has done a great amount of work in providing R and RStudio images that might be the starting point for R-based containers. And then for HPC intensive users, NVIDIA provides CUDA-based images for GPU applications, and Pawsey provides ready-to-use MPI images for parallel applications for usage on Pawsey systems. I think it's a good time to stop and take a couple of first questions from today's audience.
That sounds good. Thank you, Marco. There is a bit of dialogue going on around the installation of Singularity and where you need to install it in the system when you want to use it.
Okay.
And so just if you have some hints or tips.
Yeah, so let me quickly show you. I'm just looking for my web browser here. Okay. So if you are on a shared system, you can't install Singularity because that requires administrative privileges. But you can install Singularity, say, on a cloud instance that you're using or on your personal machine, provided you have administrative privileges. I'm not entering into full details here, but again, if you follow then the link that we give you at the end of the webinar for the tutorial materials, there is a setup page there. And here I'm providing installation script for a number of tools, including Singularity. There is also Docker that will come handy quite soon. This is quite straightforward for any Linux box. So you basically download the script. If it is a Ubuntu machine, chances are it will work. Otherwise, just take it as a template. You might need to edit it a bit, but that's a good starting point. It installs the required dependencies and then run the building of Singularity and some configuration. If you're on Mac or Windows, the best way to install Singularity is via a virtual machine engine called the Vagrant, where again you need the privileges, the root privileges to install it. But once it's there, it's beautiful because you can just spawn a Linux box from there and use the same instructions that I'm providing here. And if this is not enough, so I've recently added an episode in this tutorial material which goes into further detail on how to install Singularity on your machine. And then you can go back to this page and scroll down, have a look, and hopefully it will guide you in the process. Yeah.
Okay, that was the biggest discussion point. There was some other comments about writing comments. Do you use a hashtag, or how do you write a comment within a Singularity def file?
Ah, good point. Yeah, I never done it, and you will get the reason in a couple of minutes. But I believe that you should be able to use the typical bash hash to turn a line into a comment line.